Welcome to Session 4, the last session of Module 1. This is the practical session. Sessions 1, 2, and 3 gave you the mental model. Today, we look at the actual market as it stands, and at the far more useful question of how to choose. I want to begin with a confession about this session, because it shaped how you should use it. This is the only session in the entire course that starts going out of date the moment I finish speaking. The material was verified on the 27th of August, 2026. Between the time I built these slides and the time you watch them, models will have been released, renamed, repriced, and retired. I am going to show you a snapshot table anyway because it is useful, but the snapshot is the least valuable thing in this session. The valuable thing is the framework. By the end of the hour, you will have 6 axes for comparing any model, a decision tree that will still work in 2028, and one piece of evidence that will change how you think about medical artificial intelligence products. The subtitle is the whole argument. Stop asking which model is best. Start asking best for what. Every clinician I meet who is frustrated with these tools is frustrated because they picked one model for no particular reason, usually the first one they signed up for, and now use it for everything. That is like owning one drug. A quick look at where we are, because this closes the first module. Session 1 traced the history, from expert systems through deep learning to transformers, and made the point that the thing that changed in 2017 was research, and the thing that changed in 2022 was product. Session 2 took you inside a language model. Tokens, context windows, temperature, and the structural argument for why hallucination is not a bug awaiting a patch. Session 3 was the evidence session. Sensitivity, specificity, positive predictive value, and the worked example, where a model with an area under the curve of 0.90 produced alerts that were right 8 times in 100. Today, Session 4, is the one where you find out what is actually on the market. Notice the shape of Module 1. It was deliberately built so that the shopping session comes last. If I had opened the course with a tour of Claude and ChatGPT and Gemini, you would have spent 4 weeks comparing features. Instead, you now have the conceptual equipment to look at the same tour and ask harder questions. Module 2 begins next week with prompt engineering, and I would argue that is the highest leverage module in the whole course, because that is the point where the skill becomes yours rather than the vendor's. 6 outcomes for the hour. 1. Name the families that matter. Frontier models, open weight models, and medical tuned models, and say what each is genuinely for. Those 3 categories are not a hierarchy. They answer different questions. 2. Explain the tier structure inside a single family. This is the thing most clinicians have never noticed, and it is the single easiest way to improve your experience of these tools immediately. 3. Cite the evidence that general-purpose models have been outperforming specialized clinical tools on medical benchmarks. There is a specific study I want you to know about, because it will come up the next time a vendor pitches you a medical artificial intelligence product. 4. Compare any 2 models on 6 axes: capability, cost, latency, context window, privacy, and regulatory posture. 6 axes, and only one of them is the one everybody argues about. 5. Decide when local wins. When is an open weight model on your own hospital hardware the right answer, rather than the paranoid answer? There is a real deployment I will show you. 6. Read a benchmark score the way you now read an area under the curve, as a screening number that tells you whether to look further, never as an answer. That outcome is the bridge from last session, and it is the one I care about most. Let me start by dismantling the question I get asked most often. Which artificial intelligence is best? That question has no answer, and the reason is not diplomatic evasion. It is that the question omits the task. Asking which model is best is like asking which antibiotic is best. Best for what organism? In what patient? At what site? With what allergies? At what cost? The moment you supply those, the question becomes trivially answerable. Without them, it is not a question at all. The question that works is on the right. Which one for this task, under these constraints? And once you know the 6 axes I will give you in the second half, you can answer that in about 90 seconds. Look at the list at the bottom, because this is the practical point. Here is one clinician in one ordinary week, summarizing 90 days of notes for a complex discharge. That needs a long context window, and it is bulk routine text, so it wants a cheap, fast tier. Drafting an explanation for a mother about a grade 3 intraventricular hemorrhage. Completely different. Communication quality is the entire task. Screening 4,000 abstracts for a systematic review. Cost and speed dominate. You are running thousands of calls. Reasoning through a genuinely complex case. This is where you want the flagship tier and extended thinking, and where the extra cost and the extra 30 seconds are obviously worth paying. And anything touching identifiable patient data. Privacy overrides every other access, and we will spend real time on that one. 5 tasks, 5 different right answers. 1 clinician, 1 week. If you are using a single model for all 5, you are getting a mediocre result on at least 3 of them.
Before we go any further, I owe you an honest warning about this session, and I want to make the warning itself part of the teaching. This is the only session in the course that starts expiring the moment it is recorded. Between February and August of 2026 alone, every major family shipped at least 2 significant releases, and several shipped 4. The names, prices, tiers, and rankings on the next few slides were verified on the 27th of August, 2026, and I would be surprised if some of them are not already wrong by the time you watch this. So look at the 2 columns. On the left, everything that will go stale. Specific model names and version numbers, prices per million tokens, leaderboard positions, context window sizes, which family is currently in front. Do not memorize any of it. On the right, what will still be true in 2028. The tier structure inside every family, the 6 selection axes, the fact that privacy constraints decide more than capability does, the fact that benchmarks measure much less than they appear to, and the pattern that general models keep absorbing specialist niches. Everything in the right-hand column is the actual content of this session. Everything in the left-hand column is illustration. One practical note. Your handout has the snapshot table on a single page, page 3, deliberately isolated so that it can be reprinted on its own when it goes out of date, without reprinting the rest of the document. If you are running this course for your own department, that is the page you update annually.
Part 1. What actually exists? I want you to hold 3 categories in your head rather than 1 league table, because the league table framing is what leads people astray. The first category is the frontier families. These are the very large, closed, commercially hosted models from a handful of labs. You access them over the internet, you pay per use or per subscription, and you do not get the model itself. The second category is the open weight challengers. These are models whose weights you can download and run on your own hardware. That single property changes everything about what you are permitted to do with patient data, and it is the reason this category matters far more in medicine than it does in most other industries. The third category is the medical tuned models. Models specifically trained or fine-tuned on medical text, marketed for clinical use. This is the category most clinicians assume they should want, and it is the one where the evidence is most surprising. We will take them in that order, and then we will look at a study that puts the third category in a rather uncomfortable light.
Here is the snapshot. And remember the warning from 2 slides ago. 4 labs dominate the closed frontier. Anthropic with the Claude 5 family, where the Mythos class Fable 5 sits at the top and Opus 5 sits below it. OpenAI with the GPT 5.6 family, organized as Sol, Terra, and Luna from most to least capable. Google with the Gemini 3 line, where 3.1 Pro is the reasoning tier and the Flash variants are built for speed. And xAI with Grok 4.6. The right-hand column lists what each is commonly said to be good at. Claude for qualitative reasoning and writing, GPT for tool use and planning, Gemini for long context retrieval and multimodal work, Grok for fast iteration on real-time data. Now, read that column skeptically, which is the point of the left-hand box. Those strengths are real, but they are narrow, and they come from leaderboards that reshuffle monthly. For the ordinary clinical text work most of you will do, summarizing, drafting, explaining, restructuring, these 4 families are far closer together than the marketing suggests. In my experience, the difference between 2 frontier models on a clinical writing task is smaller than the difference between a good prompt and a bad one on either of them. That is a preview of Module 2. The amber box gives you one concrete illustration of how volatile this is. Anthropic released its Mythos-class flagship on the 9th of June 2026, suspended access 3 days later to comply with the United States Department of Commerce Export Control Directive, and restored it on the 1st of July once the directive lifted. I include that not as gossip, but because it teaches an axis people forget: availability. If you build a clinical workflow around one specific model, you should have a plan for the week it is not there, whether the reason is export controls, an outage, a price change, or a deprecation notice.
This is the slide that will change your day-to-day experience fastest, and it is the thing almost nobody notices. Every model family is not one model, it is a ladder of tiers, and they are priced and tuned differently. At the top, the flagship. Hardest reasoning, highest cost, slowest response. This is where you go for a genuinely complex case, an ambiguous differential, or the critical appraisal of a paper, where you want the model to actually think rather than pattern match. In the middle, the workhorse. And this is the important one, because the workhorse tier now delivers most of the capability of the flagship at a fraction of the cost. Summarizing, drafting, restructuring day-to-day clinical text. For the overwhelming majority of what you will do in this course, the workhorse tier is the correct answer. At the bottom, the fast and cheap tier. Near instant, very low cost, built for volume. Classification, extraction, screening thousands of abstracts. If you are running 4,000 calls, this tier is not a compromise. It is the professional choice. Now, the two mistakes, both extremely common. Running everything on the flagship burns budget and adds latency for no benefit at all on routine text. And running everything on the cheap tier gives you confident, shallow answers on precisely the questions where you needed depth, which is worse because it is invisible. Here is the practical instruction. In most consumer applications, the tier selector is a small drop-down near the message box that you have probably never opened. Open it. Look at what is in there. Try the same prompt on 2 tiers. That 5-minute exercise is worth more than any comparison article you will read.
The second category, and the one that matters disproportionately in our field, open weight models. Let me define the term precisely because it is routinely misused. An open weight model is one whose parameters you can download and run on hardware you control. No request leaves your network. That is the whole property, and it is enormous. Note what it is not. It is not the same as open source. The training data and the training code are usually not published, and the licenses vary considerably, some with restrictions that would matter to a hospital procurement office. Read the license. On the right, the families you will hear named. Kimi K3 from Moonshot, which is the largest open weight release to date. DeepSeek version 4, notable for very low cost and strong reasoning. The Quen family from Alibaba, which is the strongest on multilingual work, including Arabic, and that is directly relevant to many of you. Mistral and Mixtral, efficient and popular for high-volume inference. Meta's line, which has been the long-standing default in hospital pilots. And at the small end, models like MedGemma and Phi that fit on a single graphics card. Why does this category matter in medicine specifically? The box at the bottom left. Because the compliance perimeter shrinks back to your hospital's existing audited perimeter. There is no model provider in the inference loop, which means there is no third party to contract with, no third party to audit, and no third party to be breached. For a hospital that has already been through a data incident, or that operates under data residency rules, that is not a minor convenience. It is frequently the only viable path. And the trade is honest. Open weight models sit roughly 1 to 2 generations behind the closed frontier on raw capability. For documentation, summarization, and structured extraction, that gap is operationally irrelevant. The clinical work still gets done. For genuinely hard reasoning, it is not irrelevant at all.
The third category, and the one where I most want to change your mind, medical tuned models. It helps to split this into 2 quite different things that get discussed as if they were one. On the left, research medical language models. MedPalm, Metatron, Med42, MedGemma, OpenBio LLM. These are general models fine-tuned on medical text, examination questions, and literature. Mostly open weight, mostly published with benchmark tables in the paper. On the right, commercial clinical tools. Open evidence, up-to-date, expert AI, and similar products. These are retrieval systems built over curated clinical content, marketed directly to clinicians for point-of-care questions. Different thing entirely, sold much harder. Now the Amber Box, and the intuition every single clinician in this room has. A model trained on medicine must be better at medicine than a general one. It is a completely reasonable intuition. It was also true in 2022, when MedPalm scored around 67% on MedQA and beat everything general available at the time. Then the general models scaled. By the time GPT-4 was scoring in the 80s on United States medical licensing examination style questions, the specialist advantage had largely evaporated. And here is the pattern I want you to notice, because it is now repeated at every generation. A specialist medical model is built, and it beats the general models available at the moment it is built. Then the next general release overtakes it. The specialist model is a snapshot. The general models are a moving target. That is the general shape. Now let me show you the specific study.
This is the slide I would most like you to remember from today, and it is the one that will be most useful to you in a procurement meeting. A study published in Nature Medicine in June 2026 built a 1,000-item benchmark, 500 MedQA questions to test factual medical knowledge, and 500 health bench prompts scored against rubrics written by clinicians, which tests something much closer to whether the answer is actually any good. They compared 3 frontier general-purpose models against 2 widely deployed commercial clinical tools. Everything run at temperature 0 for reproducibility, with search enabled for all systems, so nobody was handicapped. The finding is on the right. The general-purpose models consistently outperformed the clinical tools, and the deficits were specific and, I think, clinically recognizable. Completeness, communication quality, context awareness, and systems-based safety reasoning, which is the ability to reason about the situation around the patient rather than just the fact being asked about. So what do you do with this? 3 things in the red box. First, do not assume that a product marketed for clinicians outperforms the general model you already have access to. Ask for the head-to-head comparison. If they have not run one, notice that. Second, and this is the sharper point, these clinical tools are rarely subjected to independent quantitative evaluation, even as they increasingly influence diagnosis and triage. That is exactly the evidence gap we spent last session learning to detect. It is the vendor's job to close it, not yours. Third, and I want to be fair here, this does not mean specialist tools are worthless. Curated content and auditable sourcing are genuine advantages, and for some questions, knowing exactly which guideline a statement came from is worth more than a marginally better answer. The point is that the capability claim and the sourcing claim are 2 different claims, and you should test them separately.
I have just spent a slide arguing against specialist models, so let me be fair. There are 4 situations where a tuned or locally hosted model is clearly the right call, and none of them is about raw capability. 1. The data cannot leave. If your institution's governance forbids sending identifiable patient data to any external interface, then a frontier model is simply not an option at any capability level. In that situation, a locally hosted medical model is not a compromise. It is the only thing on the table, and the relevant comparison is against doing the task manually, not against a model you are not allowed to use. 2. Narrow structured extraction. Pulling defined fields out of clinical text is a bounded, well-specified task. Small, tuned models do it well, cheaply and deterministically. And crucially, you can validate them once against a gold standard, rather than rechecking every output. That is a very different governance profile from open-ended generation. 3. Volume economics at scale. At millions of calls, the cost difference between a small local model and a frontier interface stops being trivial. I will be honest that very few neonatal workflows reach that scale, but registry-wide analyses and imaging pipelines can. 4. Auditable sourcing. When what you need is to show exactly which guideline or which paper a statement came from, a curated retrieval tool may serve you better than a more capable model that reasons beautifully and sources loosely. In a morbidity and mortality meeting, provenance can matter more than eloquence. Notice that not one of these 4 reasons is the model is smarter. That is the honest state of the field. Part 2. How to choose. This is the part that survives the churn. Everything from here to the end of the session will still be usable in 2028 when every model name I have used has been replaced. 6 axes. One of them is capability, which is the one everybody argues about online, and the one that matters least often in practice. Because at the top of the market, the differences on ordinary clinical text work are small.
Two of them decide most real decisions in a hospital, and they are privacy and regulatory posture. The other three, cost, latency, and context window, are usually constraints rather than deciders. They rule options out, they rarely rule one in. Let me take you through all six, then spend real time on cost and privacy, because those are the two where clinicians' intuitions are most often wrong, in opposite directions. 6 axes. Copy this down, or take the version on page 6 of your handout. 1. Capability. Can it do the task well? I have put overrated next to it deliberately. At the frontier, for ordinary clinical text, the gap between the leading families is smaller than the gap between a well-constructed prompt and a lazy one on either of them. 2. Cost. What does one run actually cost? We will do the arithmetic in a moment, and I suspect the answer will surprise you. 3. Latency. How long until you get an answer? Completely irrelevant when you are drafting something at your desk. Decisive for anything embedded in a live clinical workflow, where 30 seconds is an eternity. 4. Context. How much can it read at once? This one is concrete and easy to check. It determines whether 90 days of notes fit in a single pass, or whether you have to chop the admission into pieces and lose the thread between them. 5. Privacy. Whose infrastructure does your data cross? In a hospital, this is usually the deciding axis, and it overrides capability entirely. A model you are not permitted to use has an effective capability of 0. 6. Regulatory posture. Contracts, data residency, institutional approval, and availability. This is the axis clinicians forget about and that procurement departments never forget about, which is why so many enthusiastic clinical pilots die quietly in legal review. The two in red decide most hospital decisions. The first one decides most internet arguments. Those are not the same activity.
Let us do the cost arithmetic, because I think it will surprise you in a useful direction. The task. Draft a discharge summary from a 90-day admission. Realistically, that is about 15,000 tokens of notes going in and about 1,200 tokens of summary coming out. And let us say your unit does 600 discharges a year. On a flagship tier at $5 per million input tokens and $25 per million output tokens, the input costs 7.5 cents and the output costs 3 cents. Call it 10.5 cents per summary. Across 600 discharges, that is about $63 a year. On a fast cheap tier, it is about 0.4 cents per summary, or $2.70 for the year. $63 a year for your entire unit on the most expensive tier available. I want you to sit with that because it inverts the conversation people usually have. Model cost is almost never the reason not to do something clinically. The entire annual interface spend for that workflow is a rounding error against one agency nursing shift. So what does cost? The amber box, governance review, integration work, clinician time spent verifying the output, which is the big one, training, building and maintaining the audit trail. In every deployment I have seen, those costs dwarf the model spend by 2 orders of magnitude, which gives you a practical warning. If you find yourself in a meeting optimizing the per token price while nobody has costed the verification burden, you are optimizing the wrong variable by a factor of about 100. The one genuine exception is research scale. If you are screening 40,000 abstracts or running a model across an entire registry, the per token price becomes real, and the cheap tier becomes the professional choice rather than the stingy one.
Axis 5. Privacy. And the useful way to think about this is not in terms of how private is it, which is unanswerable, but in terms of a single concrete question. Whose infrastructure does your data cross? There are exactly 4 answers. 1. The consumer application. You in a browser or a phone application on a personal account. The model provider sees whatever you type. There is no institutional contract, and you personally have accepted the terms. For identifiable patient data, the answer here is never. That is the one non-negotiable rule of this course, and it has been since session 0. 2. The enterprise interface, an institutional account with a signed data processing agreement. The model provider still sees the data, but now under contract, with audit rights and defined retention. For many uses, this is acceptable once your legal and information governance teams have signed, and in practice, this is the path most hospitals take. 3. Self-hosted on rented hardware.
You run an open-weight model on cloud infrastructure you rent. This removes the model provider from the relationship entirely, but the infrastructure provider is still in it. A useful middle ground when you do not have local hardware. 4. On-premise or air-gapped. An open-weight model on hardware your hospital owns. Nobody outside your existing audited perimeter sees anything. Under strict data residency rules, this is the only option, and it carries the highest engineering burden by a wide margin. The line at the bottom is the one I want you to take away. Most conversations that begin, "Which model should we use?" skip straight past this slide, and then discover 6 months later that the answer was decided here all along.
I want to show you a real deployment rather than a hypothetical one, because on-premise is often discussed as if it were theoretical. University Hospital Bonn built an open-weight language model service running on their own hardware, processing unanonymized patient data, and it is now a permanent service for more than 10,000 staff. It was approved by clinic management, compliance, data protection, and information security, which is the part that usually kills these projects. And they published the deployment package openly so other hospitals can reuse it. But the reason I am showing you this is not the architecture. It is the evaluation finding, and it is in the 2 colored boxes. The tasks rated most useful were correcting reports, simplifying reports so patients can understand them, and looking up guideline recommendations. Notice what those 3 have in common. Every one of them is anchored to a source text that already exists. The tasks that produce the highest frequency of critical errors, clinically relevant hallucinations and omissions, were open-ended conclusion generation from findings. The model was being asked to produce something that was not in the source, nothing to anchor to. That is the transferable lesson, and it is in the teal box. The important split is not between models. It is between text-anchored tasks and generative ones. When the answer is already present in a document and the model's job is to find it, correct it, or rephrase it, performance is strong and the errors are recoverable because you can check against the source. When the model has to generate a conclusion that was not in the source, the critical error rate rises sharply. That distinction holds for every model on every slide today, frontier or local, expensive or free. So here is the instruction. Sort your intended uses into those 2 buckets before you sort your models. The bucket matters more than the model.
A modern complication on the latency axis that did not exist a couple of years ago: reasoning modes. Most current models can be asked to think before answering. The feature goes by different names: extended thinking, reasoning mode, deep think, but the mechanism is the same. The model generates a quantity of intermediate reasoning that it mostly does not show you, and then produces its answer. You pay for that in seconds of waiting and in tokens consumed. When is it worth the wait? Multi-step clinical reasoning, working through a differential, checking a calculation or a dose, critical appraisal of a paper. In short, anything where being wrong is expensive and where the path to the answer has several steps. When is it not worth the wait? Summarizing a document, rephrasing something for a parent, formatting or restructuring text, extraction against a template. Notice that these are exactly the text-anchored tasks from the previous slide. If the answer is already in the source, there is nothing to reason about. You are paying latency for nothing. And one caution, carried straight over from session 2. Longer reasoning produces more confident-sounding output. It does not guarantee more correct output. In some ways, it makes errors harder to catch, because a wrong answer that arrives with a great deal of apparent deliberation behind it is psychologically harder to challenge than a wrong answer that arrives instantly. Do not let the thinking indicator function as a quality signal. It is a latency signal.
The scoreboard. 4 benchmark families you will see cited, and what each one misses. MedQA and the United States Medical Licensing Examination style question sets. These test multiple choice examination knowledge, and the important thing about them in 2026 is that they are saturated. Everything at the frontier now scores high. A benchmark on which all the candidates score well has stopped discriminating between them, which means it has stopped being useful for choosing. PubMedQA and MedMCQA test literature and examination recall. Recall is not reasoning, and reasoning is not judgment. HealthBench is a genuine improvement because it tests realistic clinical conversations scored against rubrics written by clinicians, rather than against a lettered answer key. But it is conversation only. It says nothing about extraction, calculation, or documentation,
which is most of what you will actually use these tools for. MedHelm is broader, a suite across many real-world medical tasks. Breath helps. It is still not your unit, your protocols, or your patients. And now the Navy box, which is the bridge back to last session, and the reason I taught session 3 before this one. A benchmark score is an area under the curve. Treat it exactly the way you learned to treat one. It is a screening number. It tells you whether a model is worth investigating further, never what will happen in your unit. It was measured on a population, in this case a question set, that is not yours, and it measures discrimination rather than calibration. It tells you the model ranks well on examination items. It does not tell you the model knows when it does not know. Not one of these benchmarks measures whether a model is safe on a 24-week infant, whether it follows your unit's protocols, or whether a tired registrar at 3 in the morning can tell when it is wrong. Those are the questions you actually need answered, and you will have to answer them locally.
Here it all is as a decision tree. This is on page 9 of your handout, and I have built it so that it contains no model names at all, which means it will still work when everything on slide 7 has been replaced. Question 1, and it comes first for a reason. Does the task touch identifiable patient data? If yes, the next question is whether there is an approved institutional agreement in place. If there is, use the enterprise interface under that contract. If there is not, your options are an on-premise open-weight model or de-identifying the data first. Notice that we have not mentioned capability yet, and we are already 2 questions deep. That ordering is deliberate. Question 2. Does it need current literature or web content? If yes, you want a model with live search enabled, and you check every citation for the reasons we covered in session 2. Question 3, and this is the one from the Bond deployment. Is the answer already in a source document? If yes, the task is text-anchored, and you want the workhorse tier with no reasoning mode. That is the cheapest and fastest safe option, and it is most of what you will do. If no, the task is generative. You want the flagship tier with reasoning mode, and you verify against a source before the output goes anywhere near a patient record. Question 4. Are you running this thousands of times? If yes, drop to the fast cheap tier. And this is the important half. Validate it once, properly, against a gold standard, rather than trying to check every output by hand. At volume, hand checking does not scale, and people quietly stop doing it. 4 questions. No model names. That is the durable artifact from today.
20 minutes for the exercise, and then we will close. Take the de-identified vignette on page 10 of your handout. It is printed, it is fictional, and I want to be very clear that nobody uses a real case for this. Same prompt, 3 different models, whichever 3 the room has access to between them. Paste the 3 outputs side by side and score each one against the rubric before you start discussing. Score first, argue second. If you discuss first, the loudest person in the group anchors everyone else, and you learn nothing. 6 criteria, not to 2 each. Factual accuracy, completeness, appropriate hedging, meaning does it flag uncertainty where uncertainty genuinely exists? Register for the reader, meaning is it pitched for the audience you asked for? Safety reasoning, meaning did it flag the things that should worry you? And sourcing integrity, meaning are the claims traceable or is it at least honest about not having a source? Now, let me tell you what usually happens, because I would rather you notice it than be surprised by it. First, the total scores usually land within a point or 2 of each other. The models differ far less than the room expects, which is the whole argument of this session, arriving experimentally rather than from me. Second, and this is the interesting one, the disagreement between 2 scores in your group will usually be larger than the disagreement between 2 models. That tells you something important. The rubric and your clinical judgment applying it is doing more work than the choice of model. Third, where models genuinely do diverge, it is almost always on hedging and register, rather than on facts. And those are precisely the 2 criteria that matter most for parent-facing text, and that benchmarks measure least. Go. 20 minutes.
5 ways clinicians get this wrong. I see all 5 regularly. 1. Picking once and never revisiting. The tool you chose 18 months ago was chosen against a market that no longer exists. You do not need a committee for this. Put a calendar reminder to rerun your comparison once a year. That is the entire governance requirement, and almost nobody does it. 2. Confusing the application with the model. Claude, ChatGPT, and Gemini are products. The models inside them change underneath you, sometimes without any announcement you will notice. This matters enormously for research. If reproducibility matters, and in research it always does, record the model version string, not the product name. A method section that says we used ChatGPT is not reproducible. 3. Treating the free tier as representative. Free tiers are usually the workhorse or the fast tier with usage limits attached. Judging an entire family by its free tier is like judging a drug by a subtherapeutic dose and concluding it does not work. 4. Assuming the medical label means better. We covered the evidence. It usually means the model was tuned at a moment that is now past. Ask for the head-to-head against a current general model, and notice what happens when you do. 5. And this is the one that wastes the most institutional time. Letting capability decide a privacy question. The most capable model in the world, if you are not permitted to use it with your data, has an effective capability of 0. Answer question 1 of the decision tree first, and you will save yourself months.
That is Module 1 complete. If you remember one sentence from today, make it this one. Choose the model last. Choose the task, the constraint, and the tier first. Everything in this session unpacks that sentence. The task tells you whether you need reasoning or anchoring. The constraint, almost always privacy, tells you which architectures are even available to you. The tier tells you how much capability the task actually warrants. And only when all 3 are settled does the choice of family matter. And by then, it usually matters much less than you expected. 3 things before Module 2. First, open the tier selector in whichever tool you use and run one prompt on 2 different tiers. 5 minutes, and it will teach you more than any comparison article. Second, find out what your hospital has actually approved. Ask information governance directly. Do not assume, in either direction. I have met clinicians avoiding tools that were already approved and clinicians using tools that very much were not. Third, complete the comparison worksheet on page 11. Session 5 opens Module 2 with the anatomy of a working prompt. Role, context, task, constraints, output format, with before and after rewrites of real clinical queries. I have said several times today that the gap between a good prompt and a bad one is larger than the gap between 2 frontier models. Session 5 is where I have to prove that. Bring one prompt you actually used last week, a real one, including a bad one, especially a bad one. Thank you, and well done for getting through the foundations.